Chapter 8, Section 6, we're going to review factoring methods. We're going to first talk about what a polynomial is by definition, and then we'll move to how to factor out a GCF, which is the greatest common factor. We'll talk about factoring by grouping, and then we'll finally end with factoring trinomials. All right, a polynomial is a sum of terms whose variables have whole number exponents only. Said another way, a polynomial is a sum of terms where all of the exponents that are on the variables are only whole numbers. Remember, whole numbers are positive numbers. So 0 is a whole number, 1, 2, 3, 4, 5, 6, and so forth. No negatives, no fractions. Here's some classifications of polynomials. A monomial is a polynomial of one term. The prefix mono means one. Here's an example of a monomial. A binomial is a polynomial of two terms, the prefix bi meaning two. 7x is one of the terms, negative 8 is the second. Remember that terms are separated by addition or subtraction signs. A trinomial is a polynomial of three terms, the prefix tri meaning 3. X squared is the leading term, negative x is the second term, and then negative 6 is the third term. Any polynomial that has four or more terms is just called a polynomial, poly meaning many. Here's an example of a polynomial of four terms. Keep in mind that all of these are polynomials. A monomial is a polynomial. A binomial, a trinomial are polynomials. A polynomial of one term has a specific name, a monomial. A polynomial of two terms has a specific name, a binomial, and so forth. So all of these are considered polynomials. To be more specific, we can say monomial, binomial, trinomial. Notice that all of the exponents are whole numbers only. Hey, by the way, if an exponent is not shown, it's assumed to be 1. The variable has an exponent of 1. So all of these exponents are positive whole numbers. So all of these are polynomials. Here's our first example. They want us to factor this trinomial. It's a trinomial because there's 1, 2, 3 terms. All right. So when we factor out the GCF, which stands for the greatest common factor, what we need to do is first look at the coefficients only. The coefficients are 10, negative 15, and positive 5. The greatest common factor with respect to the coefficients only is the greatest or largest number that is a common factor of 10, negative 15, and 5. That is to say, the largest number that can be divided into 10, negative 15, and 5. That would be 5. 5 goes into 10, 5 goes into negative 15, and 5 goes into 5. So 5 is the GCF with respect to the coefficients only. So what I'm going to do is I'm going to say this trinomial is equivalent to factoring out a 5. Now let's leave some space here. Leave some space for the variables that we'll factor out in just a minute. All right. Now, this is how we fill the rest of this in. Now, I'm just focusing on the coefficients at the moment. 5 times what gives me 10? 5 times 2 gives me 10. So that goes there, okay? 5 times what is negative 15? Well, 5 times negative 3 is negative 15. Next, 5 times what gives me 5? 5 times 1 gives me 5. A positive one, by the way. All right, that's just the coefficients, okay? Now let's talk about the variables. Look at all of your x variables. This is x to the fourth power. This is x to the first power. This is x to the first power. What's the greatest number of x's that they all have in common? You cannot say x to the fourth because this term does not have x to the fourth, right? It doesn't have that many x's. Neither does this one. The greatest number of x's that you can factor out is only 1x, or x to the first power. This has an x to the first power. This has x to the first power. This has x to the first power. So that's what I'll factor out with respect to the x's right there. And so now let's fill the rest in as far as the x's are concerned. Now this is, remember, x to the first power. We can use the product rule for exponents to help us here. X times how many more x's gives you x to the fourth. X times what is x to the fourth? X times x cubed is x to the fourth. X times x cubed is x to the fourth. How do I know that? Well, the product rule says that you would add the exponents. 1 plus 3 gives me 4. Well, that leads me to something else then. I can use subtraction then to figure this out. Look at this. If you had 4 x to the fourth power to start off with in the very beginning, and you factored out x to the first power, what is 4 minus 1? 3. That's how many x's you have left over. Let's see. If this is x to the first, and you factored out x to the first, what's 1 minus 1? 0. That means you don't have any more x's left here. The same thing goes here, x to the first. So 1 minus 1 is 0. That means you don't have any more x's. Let's go for the y's. This is y cubed, y to the fourth, y squared. The greatest number of y's that they all have in common is y squared. You can't say y cubed because he doesn't have that many. You can't say y to the fourth because neither this term nor this term has that many y's. The greatest number of y's that they all share is y squared. So that's what I'll be factoring out here. Now let's use subtraction. If you had 3 y's here, y to the third power really, to start off with, what's 3 minus 2? 1. So then you have y to the first power left in this term. Let's keep going. What is 4 minus 2? 2. Okay. What is 2 minus 2? 0. That means you do not have any more y's there. Z is last. This is z to the first, z to the first, z to the first. So the best you can do as far as your z's is just z to the first. Now, if you only had one z and you factored it out, then that means you have no more z's left. Same thing goes here, z to the first, and you factored out z to the first. That leaves you with no more z's, and the same thing goes here. So this is the trinomial fully factored. So you're done. This is the GCF. 5xy squared z is your GCF, your greatest common factor. Now, if you wanted, so you're done, folks. If you wanted to check your work, distribute this GCF back in, and you will get the original polynomial back. That's how you can check every single time. Look at this binomial, 2 terms, so it's a binomial. Let's factor. So we're going to factor out the greatest common factor. Now, when you look at your coefficients, you have negative 20 and positive 10. What's the largest number that can go into 20 and into 10? 10. Very good, everybody. I always try to leave some room for the variables. Now look at your x's here. You have x to the fourth and x squared. The greatest number of x's that they have in common is x squared. Notice, I don't know if you notice the pattern, it's the smallest of the two, the smaller of the two exponents. This is x to the fourth, x squared, go with the smallest exponent. That's a little shortcut. What's the GCF with respect to the y's? This is y cubed, y to the fourth, The smallest between those two is y cubed, so that's how many I'll factor out. All right, here we go. 10 times what is negative 20? 10 times negative 2. Now, if you had 4 x's to start, you factor 2 out, how many are left? 2, so this is x squared. If you had 3 y's, or y to the third in the beginning, and you factored out all of those y to the cube, all of it, then you have no more y's left over. 10 times what gives me 10? 10 times positive 1 gives you 10. If you started off with x squared and you factored out x squared, there are no more x's. If you started out with y to the fourth and you factored out y cubed, 4 minus 3 leaves you with 1. Now, you're not done here because we always try to factor so that the leading coefficient is positive. Let's write that down. So you can see here the leading coefficient, it used to be negative 20, now it's negative 2. We don't like that. Let's continue to factor so that this leading coefficient becomes positive. All we have to do here is factor out a negative sign, or a negative 1, out of both of these terms. When I factor out a negative, there it is. I factor out the negative. That means these two terms in here change sign. This is now positive 2x squared and minus 1y. This is now fully factored. Again, if you wanted to check, which I hope you do check some of these, distribute, and you should get the original polynomial right back. All right, so you understand how to factor out the GCF from a polynomial. Now we're going to transition to factoring by grouping. Now, before we factor by grouping, I do want to try to train or coach you into remembering that the first step of any kind of factoring problem, the first step should always be factoring out the GCF. Now, what's the GCF for this polynomial? And it is called a polynomial because it's 4 terms, okay? Let's see. Does everybody have a 3? No, this term doesn't have a 3, neither does this one. Does everybody have an A? No, this one doesn't have an A, neither does this one. Does everybody have a B? No, this term doesn't have a B. So then we say the GCF is 1. Some people like to say there is no GCF, but really the GCF is 1. 1 goes into basically anything, right? So you're not going to see me factor out the GCF here. Let's factor by grouping. All right, the first step for factoring by grouping is to put all 4 terms into 2 groups of 2 terms. Now I just have a habit of putting the first 2 terms together and then putting the last 2 terms together, like that, making 2 groups of 2 terms. Now, be careful. The sign in front of the term always belongs to the term, okay? The sign in front of the term always belongs to the term. Now, you're always going to have a plus sign. I always tell my students, always put a plus sign in between your 2 groups, okay? You know that you can get rid of these parentheses, right? By the associative property of addition, you can get rid of these parentheses right now. If you erase them, you would still have the original polynomial back. The next step in factoring by grouping is to factor out the GCF from each group. Look at this group. What's the GCF here? What do they both have in common? A 3, that's right. So we'll factor out a 3. Next group, what do they have in common? A B. So let's factor out a B. There. Now, there is a sign that I am on the right track, and that sign is that this binomial factor matches this one. The fact that those 2 binomial factors look exactly the same tells me I'm doing this the right way. Now, The next step in factoring by grouping is to factor out that common binomial factor. The common binomial factor. Factor that out. So here it is. I'm going to factor it out. There it is. And then what you're left with is 3 plus b. 3 plus b is what you're left with. So times 3 plus b. Now, you're done factoring, except usually we write the variable first. I'm going to rewrite this as b plus 3, okay? Instead of 3 plus b, b plus 3. I know that addition is commutative, meaning I can write addition in any order I want. So this is the complete factorization. Now, if you wanted to check, so you're done, okay? But if you wanted to check, then you should distribute. If you distribute like this, like I'm showing, you'll get the original polynomial back. So factoring, ladies and gentlemen, is rewriting a sum of terms as a product of factors. This is, here, a product of factors. It's a binomial factor times a binomial factor. So I want to make sure that you have this in your notes so you know what factoring is. It's going from addition to multiplication. All right, let's factor. This is a brand new polynomial of 4 terms. Because it's 4 terms, I'm going to factor by grouping. But before I jump into the factoring by grouping, I want to consider what the GCF is. Notice that everything is divisible by 2. 2 actually is the GCF. But that's not it. That's not all they have in common. Notice that every single term has an x. So I'll also factor out an x from every single term. When you factor out an x out of this, 2x out of this first term, the 2 is gone. One of these x's is gone, so all you're left with is ax. When you factor a 2 out of this -4, you're left with -2. And you factored out one of these x's, so that leaves you with bx. The next term, the 2 is gone, the x is gone, leaving you with positive ay. Next, notice that the next term is negative, so I'm going to bring that down, negative, and you'll be left with 2by. All right, everybody, now what I'm going to do is I am going to factor this polynomial of 4 terms inside of here by grouping. All right, so I'm going to set up my 2 groups. Addition is right in the middle all the time. Now the 2x came out of every single term. The 2x came out of every single term. So I'm going to introduce another grouping symbol, meaning maybe like brackets, and put the 2x out front. Don't drop the 2x. Carry it with you all the way. All right, so I'm going to put ax and minus 2bx in the same group. And then I'll put ay and minus 2by in the same group. Now, you can group them differently. You can group these 4 terms differently, but I just have a tendency of doing that. All right? Next, bring down this 2x. Look at this group, and what's their GCF? What do they have in common? X. So factor out the x. That would leave you with a minus 2b. Next, what do they have in common? A y. So let's factor out a y, leaving you with a minus 2b. Notice that we're on the right track because this binomial factor is the same as this one. The next step is to factor out the common binomial factor of a minus 2b. And what remains when you do that? X plus y. X plus y. This is the complete factorization for that polynomial of 4 terms. Again, you can distribute if you would like to check your work, all right? If you choose to distribute, I have a word of caution for you. I would distribute these binomials first. I would do this first. And then, when I'm done, then I'll distribute the 2x. That's how I would do it. All right, good job, everybody. All right, notice that I'm going to example 7 here. I like this example. I want to tell you that keep track of what numbered example I'm at, because the examples that I do in my lessons are very similar to the ones that are in the textbook. I know that a lot of students prefer to see a lot of examples. They want to see a lot of examples. That's the reason why I take the time to be organized enough to keep track of the numbered example. So if ever you want to see another example like example 7 that I'm about to show you, you can open up your textbook to 8.6, look at the book's example 7, and it'll be similar to the one that I'm doing here. Okay, so it's like 2 for 1. Okay, so keep track. All right, here we go. Okay, now we're shifting to the last objective, and that is to factor a trinomial, all right? But before we get into that, what's the GCF? GCF is always first. Does everybody have an M? No. Do 11, a negative 11 and 30 share a common factor, other than 1? No. So the GCF is just 1. All right, here we go. If this factors, and I do say the word if because not all polynomials will factor. If it factors, it must factor like this. And you and I know that whatever we put here and here must multiply, right? You know how to distribute, must multiply to give you m squared. That leads us to believe that this term must be m and this one must be m, because m times m is m squared. Furthermore, you and I know that whatever we put here and here must multiply to give us a positive 30. Wait a minute. The only way you're going to get a positive product is if the signs are the same. A positive times a positive gives me a positive, or a negative times a negative gives me a positive. So which is it? Both positive or both negative? Well, look at your middle coefficient. It's negative. That tells me that this is negative and negative. All right. Next, what you want to think about are factors of this last number, factors of 30, and you're looking for factors of 30 that will sum or add up to the middle coefficient, negative 11. All right? So let's go for it. Now you know both of your factors are negative, okay? Both of your factors are negative. So let's see. Negative 1 times negative 30. Does that add up to negative 11? No. Right? Negative 2 times negative 15. Do those add up to negative 11? No. How about negative 5 times negative 6? Do those add up to negative 11? Yes. So those are the correct factors. Right? So one of these gets negative 5 and the other one gets negative 6. Negative 5 times negative 6 is positive 30. Negative 5 plus negative 6 is negative 11. Now, we're done, but I do want to say that if you wanted to check, all you would have to do is distribute, right? Distribute, and you'll get this original polynomial back. Now, you might be thinking, oh, that's, straightforward, Mr. Gutierrez. All we have to do is find factors of 30 that add up to negative 11. Factors of the last number that add up to the middle number. That's true as long as the leading coefficient is 1. So you can think that way as long as the leading coefficient is 1. If the leading coefficient is not 1, things get a little more challenging. Check out this trinomial. Consider what the GCF is. What's the GCF? Well, everybody has a 3, and that's it. I was going to say more, but that's it. This last term doesn't have any x's. The first term doesn't have any y's. So 3 is the best you can do. Factor out a 3 out of every term. That would leave you with 1x squared minus xy minus 20 y squared. Let's continue to factor. Please notice that your leading coefficient now is positive 1. In order to get an x squared, the first two terms are going to have to be x and x, because x times x gives you x squared. Now, whatever you put here and here must multiply to give you a negative number. That tells me that the signs are different. One of them is plus and the other one is a negative. Because a positive times a negative will give me a negative product. Now, all I need to do now, because the leading coefficient is positive 1, is think about factors of negative 20 that will sum or add up to negative 1. Negative 1. Let me list out a few options. Negative 20. So 20 times negative 1 definitely gives me negative 20 as a product, but it does not add up to negative 1. It adds up to 19. You can keep going. Let's see. 5 times negative 4. Close. When you add these, you get positive 1. We want negative 1. So I think the signs are wrong. How about negative 5 and positive 4? When you add these two, you get negative 1 as a middle coefficient. So then this is the correct pair of factors. These don't work. So you can see 5 is the negative factor and 4 is the positive factor. Like that. Now that's good and all, except 4 times negative 5 is negative 20. I want negative 20 y squared. So in addition to constants here, in addition to the numbers, let each of them have a y variable. That way, 4y times negative 5y gives negative 20 y squared. This is the complete factorization for this trinomial, okay? Again, I want to emphasize, if you were to distribute all of this, right, you'll get the original trinomial back. If you choose to check that, I invite you to first distribute the two binomials and then distribute the 3 at the very end. You'll see that you get this original trinomial right back. All right, check out this trinomial. Notice that the GCF is 1. In other words, they have nothing in common. Okay, so let's jump right into the factorization here. Now, this one's going to be different or more challenging because the leading coefficient is not 1. All right, we know that this term times this term must give me 3x squared. That leads me to believe that one of the terms must be 3x and the other one must be 1x, because 3x times 1x gives me 3x squared. Furthermore, the signs, this term times that term, must multiply to give me a positive 6. That means the signs are the same, either both plus or both minus. The middle coefficient in this example is positive. That concludes that both of these terms are positive terms. They're both plus, okay? So I can fill that in. Now, it's not as simple as thinking, okay, factors of 6 that add to 11. After all, that's impossible. Factors of 6 are 1 and 6, that adds to 7. Factors of 6 are 2 and 3, and 2 plus 3 is 5. So it's impossible to find factors of 6 that add to 11. That's not how we're thinking any longer, because the leading coefficient is not 1. Like I said, the leading coefficient, when it's not 1, it makes things more challenging. Now, what are the factors of 6? I kind of mentioned it a little while ago, just a minute ago. The factors of 6 are 1 times 6 or 2 times 3. Thankfully, there's not many options. So what I'm going to do right now is I'm going to play around with these factors and see which one is the right one. Now, I see that 3x times 6 is 18x. That's already too much. I'm trying to get 11x, and this is 18x. That's too much. So I can see right away that this is not the right factorization. Well, maybe 6 and 1 were in the wrong spot. Let's see if I can get 11x by switching the 6 and the 1. Well, let's check. 3x times 1 is 3x, and 6 times x is 6x. Does this sum to 11x? No. So then this is not working either. So what I'm showing you is the trial and error method, trying different factors out and seeing what works. So we just figured out that this pair of factors is not working. So let's try the 2 and the 3. Okay? Try the 2 and the 3. Here we go. So if the 2 is here and the 3 is there, let's check to see if that works. 3x times 3 is 9x, and 2 times x is 2x. This sums to 11x. Bingo, that is what we were trying to get. We have found the factorization for this trinomial. So I can box this confidently knowing that this is fully factored. All right? Keep in mind that a polynomial does not have to factor. It is possible that a polynomial does not factor. If a polynomial does not factor, you call it a prime polynomial. All right, next example, it's a trinomial. The first thing we should probably consider is factoring out the GCF. Notice that every single term has m cubed. So m cubed is the GCF. I would love it if you pause this video and see if you can fill in what the resulting trinomial is after factoring out m cubed from every single term. All right, I hope you got the following. 4n to the fourth minus 11n squared plus 6. All right, we could be done, or this trinomial that results inside could factor further. So let's try. Now, we know that whatever you write here and here must multiply to give you 4n to the fourth. Well, there's a few different ways to make that happen. One thing you could do is 2n squared times 2n squared. That might work because 2n squared times 2n squared is indeed 4n to the fourth. Now I can tell that the signs are going to be the same because this last term is positive. I can see that they're both going to be negative. Both signs will be negative. Now, you and I listed the factors of 6. We listed the factors of 6 a little while ago. So factors of 6. We know both of the factors have to be negative factors, right? So negative 1 times negative 6 or negative 2 times negative 3. Again, thankfully there's not many factors. So let's try this out. Remember, you're trying to achieve negative 11 as the middle coefficient. If I put the 6 here and a 1 here, does that work? Well, this would give me negative 2n squared. This would give me negative 12n squared, excuse me. This gives me negative 14n squared, which does not work. That's not the middle coefficient that I was looking for. So then that's not working. Well, maybe it's just that the 6 and the 1 are in the wrong position. Let's see if we switch them, if it works then. All right, give me a second just to switch them. So let's try a 1 here and a 6 there. Does that work? Well, you would get negative 12n squared and a negative 2n squared, which is negative 14n squared. So it just changed the sign. It doesn't work. All right? So let's get rid of that. All right, how about the 2 and the 3? Does that work? Well, 2n squared times negative 3 and negative 2 times 2n squared. Let's check it. You would get negative 6n squared minus 4n squared. No, that's negative 10n squared. Man, we were close, right? We wanted negative 11, we got negative 10. Well, again, maybe the 2 and the 3 are in the wrong place. So switch the 2 and the 3. How does that work out? Let's check now. We would get, sorry, just give me a second. We would get negative 4n squared minus 6n squared. It's still negative 10n squared. So it didn't work. We've tried both of these and neither of them work. But wait a minute. Maybe what we need to do is change these first terms. Maybe it's not 2n squared and 2n squared after all. Maybe there's a different way to do this. Notice that another way to get 4n to the fourth is by doing 4n squared times 1n squared. That's 4n to the fourth when you multiply. Let's try this. All right, so let's see. If we put a 3 here and a 2 here, let's try that out. 4n squared times negative 2 gives you negative 8n squared. And this product gives you negative 3n squared. Look at this, negative 11n squared. Bingo. This is the correct factorization. It took us a few tries to get it, but we were persistent. We didn't give up. This is the factorization. Now, do not forget the GCF that you factored out from the very beginning. All right, example 12 is going to be the last one, and I want you to try these on your own. There's going to be 2 of them, okay? So here's the first one. Let me write that a little neater here. So example 12, part A. You have x squared plus 13x plus 36. Go ahead and give this a try. So pause the video, please. Give this a try on your own. I'll check in with you in just a minute. All right, what I noticed right away is that the GCF is 1, so I won't be factoring out any kind of GCF. Another thing that I realized is that the leading coefficient is 1. I love it when the leading coefficient is 1 because it makes my factoring job much easier. All right, so I set up my factorization, my parentheses, right, 2 binomials, and I must get x times x in order to get x squared. Furthermore, I look at this last term and it's positive. That tells me that the signs are the same. The middle coefficient now tells me that both of the signs must be positive. Now I start thinking about the number 36. I start thinking about different factors. Of course, you got 1 times 36, you have 2 times 18, you have 3 times 12, you have 4 times 9, you have 6 times 6. There's a lot of factors. But remember that you're looking for the pair of factors that adds or sums to 13. Well, there's only one such pair, and that's 4 and 9. 4 plus 9 is 13. So I'm going to put 9 in one of them and 4 in the other. And it doesn't matter which one you put in which one. So there's the factorization. How did you do? I hope you got that one right. All right, let's do one more before we end this lesson. All right, last example, and I'm going to ask you again, I'm going to invite you to pause the video and try to factor this trinomial. All right, I noticed that the GCF is 1, so I won't be factoring that out. I also noticed that this is going to be a little more challenging, probably, because the leading coefficient is not 1. So I am not thinking about factors of negative 5 that add up to negative 12. No. All right? So here we go. Now, there's a few ways to get 9c squared. I can do 9c times 1c, or I can do 3c times 3c. I'll just give this a shot. 3c times 3c. Hey, if I'm wrong, that's what the eraser's for, but I'll at least give this a shot, okay? Now, I notice that this last term is negative, and that tells me that the signs will be different. One of them will be plus, the other one will be minus. Also, I noticed that this last number is prime. So the only factors of 5 are 1 and 5. So I put 5 in one of them, put 1 in the other. 5 in one, 1 in the other. Like that. Now, I don't want to just get negative 5. I want to get negative 5d squared. So let's also put a d on this, okay? All right, let's check it out. And if it's wrong, no worries. We'll change it, all right? So 3c times 3c, that's 9c squared. How about 3c times negative 5d? That's negative 15cd. How about 1d times 3c? That's positive 3cd. What about 1d times negative 5d? That's negative 5d squared. These two middle terms are like terms. We can combine them. So then this is 9c squared minus 12cd minus 5d squared. Bingo! We got it. So this was the correct factorization. All right, everybody, this is the end of this lesson. I hope you learned a lot. Or maybe for some of you, it was a good review. Either way, I hope you enjoyed the lesson. I'll catch you in the next lesson, 8.7, which will be more review of factoring. But it's going to be a review of factoring binomials, all right? We haven't really focused on that yet. All right, I'll catch you later.